The Copenhagen lab was unusually silent the morning Dr. Mette Jorgensen arrived to find her sequencing run cancelled. Overnight, Denmark's intelligence service had issued a stark warning. Continued collaboration with China's BGI group risked funneling Danish DNA into military programs in Beijing. Within hours, the university froze joint projects and a decade long partnership, one that powered breakthroughs in rare disease diagnostics, was gone. Dr. Jorgensen's patients would still get care, but weeks of delay now separated them from a definitive genetic answer. What happened in that hushed corridor is happening across borders, science entangled with national security, data becoming leverage, and biotechnology, once the quiet engine of medicine, stepping onto the geopolitical stage. Today, we pull three threads: the economics driving biotech's boom, the policies tightening its flow, and the power contests reshaping who controls the molecules of life. Welcome as you're listening to Thread by Thread, a podcast where each episode unravels a new thread, connecting stories of power, people, and the forces shaping our world. I'm Dheeraj Kumar. In 2024, the global biotechnology market swelled to $546 billion, a 13% leap that defied economic headwinds and high interest rates. By most estimates, we are staring at a trillion-dollar industry before the decade closes. But behind these staggering numbers lies a story of both unprecedented opportunity and dangerous concentration, one that reveals how power, money, and innovation collide in the biological age. Walk into any venture capital office in Boston or Palo Alto today, and you'll hear the same refrain. Biotech is hot, but only for the chosen few. In 2024, $26 billion in venture capital poured into biotech startups, yet this wasn't the democratizing flood of the pandemic boom. It was a selective torrent that concentrated into what industry insiders call mega rounds. 3/4 of all private investment flowed to companies raising at least $100 million at once. The median biotech venture round hit $93 million in the first quarter of 2025, enough to fund a small pharmaceutical company's entire pipeline just 5 years ago. Consider Zyra Therapeutics, which raised a staggering $1 billion in a single round, simply because former Genentech and Johnson & Johnson executives were at the helm. Meanwhile, brilliant researchers with breakthrough ideas but no celebrity pedigree struggle to secure even basic seed funding. This creates a profound paradox. The biotech economy is simultaneously flush with cash and starved of true innovation at the margins. But the real transformation is happening in the supply chains that make modern biotechnology possible. China has quietly become the beating heart of global biotech manufacturing. About 90% of the active ingredients for common antibiotics flow out of Chinese factories. Companies like WuXi AppTech and BGI Genomics don't just offer lower costs, they offer speed, scale, and capabilities that Western competitors struggle to match. The numbers tell the story of China's meteoric rise. Between 2013 and 2023, China's share of the global drug development pipeline exploded from a mere 3% to nearly 28%. Chinese pharmaceutical companies' combined market values soared from $3 billion to over $380 billion in just half a decade. Today, 1 in every 3 new drugs licensed by a multinational pharmaceutical company originates from China. This isn't just about manufacturing anymore, it's about innovation leadership. Chinese biotech companies now produce 48% of all bispecific antibodies in clinical trials, 35% of gene therapies, 30% of cell therapies, and 21% of RNA products under development globally. When Dr. Mazia Shedman at the Fred Hutchinson Cancer Center needed a better, safer drug for his blood cancer patients, he turned to zanubrutinib, developed not in Cambridge or Basel, but by Beijing-based Beijing. The gravitational pull is unmistakable. In Suzhou's biotech hub, startups like Innovent churn out biological drugs at 1/10 the US manufacturing cost, while filing more patents per year than most European countries combined. Until recently, this seemed like a win-win. Western innovation meets Eastern efficiency, creating cheaper medicines for everyone. Then came the disruption. In February 2025, the US Commerce Department reclassified high parameter flow cytometers and advanced mass spectrometers under new export controls. These aren't obscure laboratory toys, they are essential for developing mRNA cancer vaccines and CRISPR based therapies. Any American company shipping these tools to China or even collaborating digitally on projects involving them now needs a license that's almost certainly going to be denied. For Maya Lin, CEO of a CRISPR based diagnostics company in California, this wasn't just bureaucratic noise. We had a pipeline ready for China's 1.4 billion strong population, she explains. Suddenly, our best technology and half our potential market vanished. Our investors reevaluated our valuation overnight. The economic ripple effects are already visible and accelerating. European sequencing startups report 15% cost increases after rerouting sample preparation from Shenzhen to Dublin. Delays for restricted laboratory equipment have stretched from 6 weeks to up to 9 months, a lifetime for rare disease patients whose treatments depend on cutting edge diagnostics. Venture capital firms that just last year backed borderless drug discovery now actively steer founders away from any supply chain or market exposure to China, fearing future legislative crackdowns. The irony cuts deep. Just as artificial intelligence promises to revolutionize drug discovery, as gene therapies offer one time cures for inherited diseases, and as personalized medicine tailored to individual genetic profiles becomes reality, the industry finds itself fracturing along geopolitical lines. The economic logic that made biotech global, shared costs, distributed risks, faster innovation, is colliding with the security logic that's making it national. Consider the math. Complete decoupling could add years to drug development timelines and billions to research costs. A recent Federal Reserve Bank of New York report found that export controls cost the average affected US biotech supplier $857 million in lost market capitalization, with total losses across all suppliers reaching $130 billion. Companies describe an innovation toll. If you want secure supply chains, you pay extra and wait longer. If you want the best tools without legal headaches, your addressable market shrinks dramatically. This creates a cascading economic paradox. The National Security Commission on Emerging Biotechnology urges Congress to invest at least $15 billion into domestic biotech capacity while slowing Beijing. Europe pursues its own Critical Medicines Act, but every dollar spent building parallel systems is a dollar not spent on breakthrough research. Every month wasted establishing redundant supply chains is a month that patients with aggressive cancers or rare genetic diseases don't have. The transformation extends beyond costs to the very architecture of innovation. Friendshoring, redirecting manufacturing to trusted allies rather than bringing everything home, has become the new buzzword. India emerges as a key beneficiary, leveraging its existing pharmaceutical base and democratic governance to capture biotech manufacturing fleeing China. But as the Biotechnology Innovation Organization warns, reshoring or friendshoring manufacturing could take 8 years, time that an aging population and rising disease burden can't afford. The stakes couldn't be higher. Biotech's promise cheaper, better, faster medicine for a connected world now bends to the imperatives of national security and economic sovereignty. The old model, where ideas could be born in Boston, developed in Shanghai, and manufactured wherever costs were lowest, is giving way to something more complex, more constrained, and ultimately more expensive. The next time you see a headline about AI predicting cancer drugs or CRISPR eliminating genetic diseases, remember the invisible threads of capital, ingredients, talent, and regulation that must align across continents. When trust frays anywhere in that chain, innovation slows everywhere, and patients, especially those battling the rarest and most aggressive diseases, wait in the crossfire. The transformation of biotechnology from scientific collaboration to geopolitical battlefield didn't happen overnight. It began with data, specifically with the growing realization that genetic information isn't just medical data, it's strategic intelligence that can reveal vulnerabilities, enable surveillance, and shape the future of human enhancement itself. Picture this. In March 2023, the United States Commerce Department added BGI Research, BGI Tech Solutions, and Forensic Genomics International to its entity list, the same blacklist that houses Huawei and other Chinese tech giants. This wasn't routine bureaucracy. It was the moment when genetic sequencing officially became a matter of national security. The allegations against BGY were specific and damning. US intelligence agencies claimed that the company's non-invasive prenatal testing kits, marketed globally under the brand Nifty and used by millions of pregnant women, were systematically harvesting genetic data that could give China a path to economic and military advantage. The scope was staggering. BGI's tests had been administered in over 52 countries, creating what some intelligence analysts described as the world's largest foreign genetic database. But this wasn't just about collecting DNA sequences. The real concern was correlation, linking genetic information with medical histories, demographic data, and behavioral patterns to build comprehensive profiles of entire populations. When Denmark's intelligence service warned that continued collaboration with BGI could allow Danish genetic data to fall into the hands of China's military, they weren't speaking hypothetically. They were referencing BGI's documented involvement in genetic surveillance programs targeting Uyghurs and other ethnic minorities in Xinjiang. The evidence was overwhelming. BGI had helped establish DNA databases for Xinjiang public security, participating in what rights groups called genetic apartheid, the systematic collection and analysis of biological markers to track and control ethnic populations. The same company processing COVID-19 tests in European labs was simultaneously enabling the most extensive genetic surveillance program in human history. BGI's response was predictably defensive. The company denied any military connections, dismissed US sanctions as market protectionism in disguise, and insisted it does not engage in unethical practices. But the damage to trust was irreversible. Within months, universities across Europe began auditing their BGI partnerships, and public health agencies started questioning whether speed and cost savings were worth potential security risks. China's retaliation was swift and systematic. In late 2024, Beijing expanded its export control regulation to cover not just physical products, but algorithms, genetic analysis software, and even anonymized genomic datasets. The message was unmistakable. If the West wanted to decouple from Chinese biotechnology, China would make that decoupling as economically painful as possible. This escalating contest reached its crescendo with the Biosecure Act, which passed the US House of Representatives on September 9, 2024, with overwhelming bipartisan support, 306 votes to 81. The legislation would bar federal agencies from doing business with BGI, Wuxi EpTech, Wuxi Biologics, Complete Genomics, and MGI, along with any subsidiaries or affiliates. More importantly, it would prohibit federal contractors from using services or equipment from these companies, effectively creating a parallel biotech ecosystem. But Biosecure's journey through Congress revealed the complex realities of biotech decoupling. Despite House passage, the bill stalled in the Senate and ultimately failed to become law in 2024. Industry lobbying was intense. Pharmaceutical companies warned that cutting ties with Chinese contractors could delay drug development by years and increase costs by billions. The 8-year grace period originally included in the legislation reflected industry concerns about the time needed to build alternative supply chains. The failure to enact Biosecure doesn't mean the pressure has disappeared. If anything, it's intensified and evolved. The incoming Trump administration signals continued focus on China containment, and with Republicans controlling both chambers of Congress, a new version of the legislation seems likely in 2025. Industry sources suggest the new bill may have a shorter transition period and broader scope, potentially covering research collaborations and data sharing agreements that the original version exempted. Europe has chosen a different path, but the destination looks increasingly similar. In June 2025, the European Union deployed its international procurement instrument for the first time, excluding Chinese companies from public medical device contracts worth more than 5 million euros. The move, justified as a response to China's discrimination against European firms, marked a fundamental shift from economic integration towards strategic autonomy in healthcare. China's response followed predictably. Within weeks, Beijing announced its own restrictions on European medical device companies, mirroring EU actions by excluding European firms from government contracts worth more than 45 million yuan. The tit for tat escalation continued with Chinese anti dumping duties on European brandy and extended investigations into EU pork imports. A reminder that biotech sanctions don't occur in isolation. This is where the contest becomes truly complex, the intersection of economic interdependence and security imperatives. Intelligence analysts and policy strategists now describe three potential scenarios emerging from this competition, each with profound implications for innovation, patient care, and global stability. The first scenario is complete technological decoupling, what policymakers euphemistically call comprehensive de-risking. Under this model, the United States, Europe, and their allies would create entirely separate biotech ecosystems, with China-free supply chains for anything touching national security. Drug developers would need parallel manufacturing systems, one serving NATO markets, another serving Asia. Research collaborations would end, data sharing would stop, and the global scientific community would fragment along geopolitical lines. The economic implications are staggering. A recent study by Roland Berger found that comprehensive decoupling could reduce China's real GDP by 2.3%, while causing significant damage to Western economies. Germany would see a 0.8% GDP decline, more than 5 times the impact of Brexit. For biotechnology specifically, complete decoupling could add years to drug development timelines and billions to research costs as companies struggle to replicate Chinese manufacturing capabilities and research infrastructure. The second scenario is selective decoupling, a middle path where low-risk collaborations continue while sensitive areas become strategic assets. Agricultural biotechnology might remain global, as might basic research tools and generic manufacturing. But human genomics, personalized medicine, and anything involving population-scale health data would be treated like advanced semiconductors or classified defense technology. This approach preserves some economic benefits while limiting security risks, but it requires constant recalibration as technologies evolve and threats emerge. The challenge with selective decoupling is defining boundaries. Is a plant genome sequencer used for crop improvement a security risk if it could also analyze human DNA? Should academic exchanges continue for basic research but end for translational medicine? The complexity of modern biotechnology makes such distinctions increasingly arbitrary and difficult to enforce. The third scenario, and perhaps the most likely, is friend-shoring, redirecting supply chains to trusted allies rather than bringing everything home. India emerges as the primary beneficiary, leveraging its existing pharmaceutical manufacturing base, English-speaking workforce, and democratic governance to capture biotech production fleeing China. Vietnam, Thailand, and other Southeast Asian nations would play supporting roles, offering lower costs and fewer political risks than their giant neighbor. But friendshoring faces its own challenges. India's pharmaceutical sector, while large, lacks the advanced biomanufacturing capabilities needed for mRNA vaccines, cell therapies, and complex biologics. Building such capabilities could take a decade and require massive infrastructure investments. Vietnam offers manufacturing expertise but limited research capacity. Neither country has the comprehensive supply chains and skilled workforce that made China attractive in the first place. Meanwhile, the human cost of this geopolitical contest continues mounting. Patient advocacy groups across Europe and North America warn that biotech nationalism will delay treatments for rare diseases, increase drug prices, and reduce access to cutting edge therapies. The Danish patients whose genetic testing was disrupted by security warnings represent a larger pattern, science slowing when politics intervenes. Consider the implications for genomic medicine, where international collaboration has been essential for progress. The Human Genome Project succeeded because it was truly global, with teams from 6 countries sharing data and resources freely. Today's equivalent, efforts to understand genetic variants across diverse populations, requires even broader cooperation. When Chinese researchers can't access American databases or European scientists hesitate to share data that might end up in Chinese military programs, the pace of discovery inevitably slows. The stakes extend far beyond traditional medicine. Advances in synthetic biology could enable new materials, clean energy technologies, and food production systems. Gene editing tools like CRISPR promise to address climate change, enhance crop yields, and eliminate genetic diseases. But these breakthroughs depend on global knowledge sharing, open scientific collaboration, and trust between researchers across borders. DNA data security has become a particular flashpoint because genetic information is simultaneously personal and political. Unlike credit card numbers or social security identifiers, genetic data cannot be changed if compromised. It reveals information not just about individuals, but about their relatives, their communities, and potentially their nations. As one US intelligence official warned, in the wrong hands, genomic data poses serious risks not only to the privacy of Americans, but also to US economic and national security. The privacy implications are staggering. Modern genetic analysis can infer physical appearance, disease susceptibility, and even behavioral tendencies from DNA samples. When combined with other data sources, social media, location tracking, purchasing patterns, genetic information becomes a tool for unprecedented surveillance and control. China's use of DNA collection to track vigors demonstrates how genetic surveillance can enable systematic oppression. But privacy concerns cut both ways. American and European companies also collect vast amounts of genetic data through direct to consumer testing, clinical trials, and hospital partnerships. The difference, supporters argue, is democratic oversight and legal protections that don't exist in authoritarian systems. Critics counter that Western companies have repeatedly misused health data and that genetic information is too sensitive for any single entity to control. As this contest intensifies, a fundamental question emerges: can biotechnology maintain its innovative momentum while serving geopolitical objectives? The answer may determine not just who leads in the next phase of biological revolution, but whether that revolution benefits humanity or becomes another arena for great power competition. The optimistic scenario envisions competition, spurring innovation, multiple countries racing to develop better treatments, more effective vaccines, and novel therapeutic approaches. Historical precedents like the space race suggest that geopolitical rivalry can accelerate scientific progress when properly channeled. The pessimistic scenario sees fragmentation undermining innovation, duplicate research, restricted collaboration, and resources diverted from breakthrough science to building parallel systems. Small biotechs may be unable to navigate complex compliance requirements. Innovation could concentrate in large corporations with government connections, and scientific progress could slow just when humanity faces its greatest biological challenges. The truth likely lies somewhere between these extremes, but the trajectory depends on choices made in the next few years. Will governments prioritize security over efficiency, even when the costs are measured in delayed treatments and higher drug prices? Will scientists find ways to collaborate despite political constraints, or will nationalist pressures fracture the global research community? Can new institutions emerge to facilitate trusted cooperation, or will existing frameworks crumble under geopolitical stress? Dr. Jurgensen's Silence Laboratory in Copenhagen offers a preview of this future. What began as a security advisory became a lived experiment in the geopolitics of science. Her patients received care, but at what cost? How many breakthrough treatments will be delayed because researchers can't access the best tools? How many lives will be affected because scientific progress must navigate political boundaries? The irony is profound. Just as biotechnology promises its greatest breakthroughs, AI assisted drug discovery, gene therapies for inherited diseases, personalized medicine tailored to individual genetic profiles, the industry finds itself constrained by the very success that made it strategically important. The more powerful biotech becomes, the more it attracts political attention. The more it shapes national competitiveness, the more it becomes subject to national control. This creates a paradox at the heart of modern biotechnology. The field's greatest strength, its ability to cross boundaries between disciplines, institutions, and nations, becomes a vulnerability in an age of strategic competition. The same openness that enabled rapid progress now raises security concerns. The same global networks that accelerated innovation now create dependencies that governments seek to control. The biotech Cold War has begun, but its outcome isn't predetermined. The choices made in boardrooms and capitals over the next few years will determine whether the biological revolution unfolds as a global collaboration or a zero-sum competition. Either way, the DNA is already out of the bottle, and there's no putting it back. Economics told us the incentives: faster discovery, lower costs, better treatments for more people. Geopolitics reminds us that those incentives collide with sovereignty, security, and the fundamental question of who controls the future of human biology. The thread connecting them is trust: trust in institutions, in intentions, and in the promise that scientific progress serves humanity rather than just the highest bidder or the strongest military. Where that trust phrase, patients wait longer, costs rise higher, and innovation slows. The stakes couldn't be clearer or more personal. They're measured in the time between diagnosis and treatment, the price of life-saving drugs, the distribution of biotech jobs across the globe, and ultimately in who gets to define what it means to be human in the biological century. That's another thread pulled, but the fabric still tangled. If you found something worth thinking about, consider following the show and sharing it with someone who might too. You can listen to all episodes on Spotify, Apple Podcasts, or wherever you get your podcasts. I'm Dheeraj Kumar, and I'll see you next time as we pull another thread from the fabric of our world.